Section 4. Reaction Types and Chemical Equations. ChemTalk. Chemical reactions. Kinds of chemical reactions. A chemical reaction takes place when starting materials or reactants change to new materials or products. Synthesis, decomposition, single replacement, and double replacement reactions are some common kinds of chemical reactions. Synthesis and decomposition reactions. Synthesis means putting together. In a synthesis reaction, two or more substances, elements or compounds, combine to form one or more compounds. In this investigation, you explored the reaction of magnesium and oxygen to form magnesium oxide. The opposite kind of reaction is a decomposition reaction. In chemical decomposition, a compound is separated into its elements. Electricity can be used to decompose water into hydrogen and oxygen. Single replacement reactions. A single replacement reaction is one in which an element reacts with a compound to produce a new element and an ionic compound. For example, a single replacement reaction occurs when you put a strip of zinc into hydrochloric acid. Hydrogen gas and aqueous zinc chloride are formed, as you observed in section 1. Activity series. A single replacement reaction occurs when you put a strip of zinc in a copper 2 sulfate solution. The zinc metal exchanges places with the copper cations. If you put copper metal in a zinc sulfate solution, you would find that no reaction would take place as expected. Zinc atoms exchange places with copper ions, but copper atoms will not exchange places with zinc ions. You have learned something about a property of copper and zinc. Zinc is more reactive than copper. If you were to experiment with different metals in metallic solutions, you should be able to create an activity series of metals. The activity series of metals can be put into a table that you can use to predict if a reaction will take place. The table looks like the one on this page. The table permits you to determine how a metal will react in a metal solution. A metal that is more active than another will dissolve into the metal solution and plate out the less active metal. Zinc replaced the copper in the copper 2 sulfate solution, and the copper plated the zinc. For example, let's say that you place a strip of copper in a silver nitrate solution. According to the table, the copper will dissolve into copper ions, and the silver ions in the silver nitrate solution will plate out on the copper as silver. In addition to metals, you will notice that hydrogen gas is also listed in the activity series. You read above that metals can replace less active metals in metal salt solutions. Metals that are more active than hydrogen can replace the hydrogen from water to form metal hydroxides. As an example, if you were to react potassium metal with water, you would get hydrogen gas and potassium hydroxide solution. The equation is double replacement reactions. Double replacement reactions are different from single replacement reactions in that you start with two aqueous phase solutions, and when they are mixed, they switch partners. An example of this type of reaction is, note that the cation of the one compound, Ba2 positive, they're talking, okay. exchanged places with the cation sodium of the other compound. Okay, so they're talking about, okay. All right. The solid is a precipitate. When examining double replacement reactions, you know that a reaction has taken place if you see a precipitate or a gas. Solubility rules. A precipitate will form if the compound is not soluble in water. In the example above, okay, let me scroll up so we can look at that example while I read this. Let me, so you can visualize it better. Okay. In the example above, so as you're reading this, you're looking at this equation. All right, in the example above, barium sulfate was not soluble in water. Okay. This was noted in the equation by referring to it as a solid, S. Okay, so here's barium sulfate, and it's being referred to as a solid, meaning that it's not soluble in water. Chemists have created a set of solubility rules for salts. Salts are classified as ionic compounds having both cations and anions. In the example above, barium sulfate, right here, formed as a precipitate. Since barium sulfate is insoluble, this agrees with the solubility rules. If you mixed silver nitrate with sodium chloride, would you expect to get a precipitate? The two products that would form are silver chloride and sodium nitrate. Solubility rule 2 tells you that silver chloride is insoluble. A precipitate will form. And solubility rule 3 tells you that sodium nitrate is soluble and stays in solution. Using these rules, you can now predict whether a mixture will produce a precipitate or not. And then here's the following, and these are the solubility rules. All salts defined as ionic compounds of alkali metal group 1 on the periodic table and the ammonium ion are soluble in water. All chlorides, bromides, and iodides are soluble with the exception of silver, lead, and mercury halides. All nitrate, chlorate, perchlorate, and acetate salts are soluble. All sulfates are soluble with the exception of calcium, barium, strontium, and lead. All carbonates, phosphates, chromates, hydroxides, and sulfides are insoluble except when they are combined with alkali metals or the ammonium ion. And again, guys, remember, soluble means it dissolves in water. Insoluble means that it does not dissolve in water.